All right. So some of these topics is going to be kind of challenging because we haven't done them since like November, right? Or yeah, middle of November is when we switched over to this. So we'll want to make sure we remember what they are, and make sure you ask questions in practice here this morning so that you're ready to do your assignment. All right, so we're going to start with order of operations. What word can I use to remind me the order in which I do operations in mathematics? Headmass, look at this. Where are we remembering everything? Headmass, of course, stands for brackets, exponents, division, multiplication, addition, and subtraction. So make sure we do those in those orders, and we go from there. We'll make sure we get this written down. Remember, you get to use this to complete your assignment, so make sure you get it written down. All right, so in the first one, do I have any brackets or exponents? So, are there any brackets or exponents to do in this one? No. Any multiplication or division? No. So we're just going to add or subtract in the order that we see them. So I would just do the first addition. 5 plus 3 is, and then minus 7. 8 minus 7 is 1. Now you might do it all at once. That's totally fine. And we get 1. How about in B though? 1 plus 5. Right, we got to do the brackets part first. So we're going to do the 1 plus 5. So the 1 plus 5, of course, is 6. So what I do is just like to do one step at a time. We don't want to go do too many steps, because when we do too many steps at once, that's when we make our mistakes. Can I add 4 plus 2 now? Okay, I got to do the divide by 3. Yeah, and we also have a 2 times 6, right? We see multiplication or division. Now, even though BESMAS says division first, you can do multiplication as well. Either of those you can do in the order they appear, okay? So both is going to be correct, but it sounds like if we do it in the order that we see that, we're going to go 2 times 6 first, which is 12, divided by 3. Now, can I add the 4 plus 12? Still going to do the division. And now I can finally add them together to get 8. Now, had we done what Landon suggested, we could have done 12 divided or 6 divided by 3 and get 2. And then 2 times 2 is 4. Okay, so that's why the order in which you multiply or divide doesn't matter. It does matter whether you add or subtract before you multiply or divide. So make sure we get those right. Okay, how about in this one? Mm-hmm. All right, great. So I did the operation inside the brackets. Oh, we got to do the exponent next, right? Don't get suckered in here and try and do 4 times 2. That's multiplying before the exponent. We got to do the exponent. The exponent 2 means what? Yeah, multiply by itself. 2 times 2, which in this case is 4. Just like in the other question, I've got a multiplying and a dividing. So as long as I do them in the order that I see them, then it's fine. Help me out here. 4 times 4. 16. $16 divided by 8. Then finally, I get to add that 5. Okay. D. BEDMAS, brackets. So I see brackets, but are there any operations inside the brackets? No. The brackets are there to help you separate the numbers. But I do see an exponent. Now be careful on this one. This is -3 squared. So squaring means it gets multiplied by itself. So this is a negative times a negative, which is going to be positive, yes. Landon's telling me to do 5 times 4 first. Can I do 10 plus 5? No, that would be adding before multiplying. We can't do that, so good. Excuse me. Now I've got adding and subtracting. Do them in the order that I see them. 9 plus 20 is 29. Minus 12, which I think is 17. Excellent. Any questions? So far, so good? Good. This is also something that I promised you when we started doing integers and things like that back at the beginning. Maybe we were struggling, but I said we'd be doing it all year. And by the end of the year, it would all come together. And I think this is evidence of that. Okay. Again, I see brackets. Are there any operations inside those brackets? No. They're just helping us with the integers. Do you see any multiplying? Not really. What I do see is this minus minus. When you minus minus, you're taking away cold. What does that become? Yeah, it's like getting warmer, right? Remember when you minus minus, if you're subtracting a negative, you're taking away cold, so you're actually going up. So some people would prefer to rewrite this and say minus minus is actually like plus 2. Okay, now you don't need to do that step. You could do it as you're going along. So you do all these numbers, and then when you get down to here, you say I'm subtracting a negative, which is taking away cold, so I actually get warm. And do the add 2 at the end. But now I think we can go through all these steps in one. Let's start at -5, which is pretty cold. Subtracting 3, am I getting colder or warmer? -5. And I subtract 3. -8, so that gets me colder, right? -5 minus 3 is -8, so I'm at -8. Plus 6, where am I? Yeah, I'm getting 6 warmer, so -2, not quite at 0. Add 2 to that gets me at 0, that's right. Now this is where our calculator can be helpful. If you type this in as you see it on there and say -5 minus 3 plus 6 plus 2, you'll also get a 0. Okay? Or you might want to do it in a couple of steps, like I did in the first one. Do the first addition and subtraction, then go off. But I think we're fine. In F, do you see any that we can simplify? Any things, you know what we did with the -2? Can you do anything similar in this one?
Minus with the
Yes.
-8 and -7.
So what is it -7 actually like?
+7.
Yes. And it's one of those when you say it, it even sounds weird, right? When you say minus minus, why am I saying it twice? That double negative makes it a positive anyways. You're subtracting cold. So let's see if we can do this one in our head. We're -9, pretty cold. Add 1, where am I? -8, I'm a little bit warmer. -8. Yeah, now I'm way down really cold. Plus 7, -9. Yeah. Okay. Any questions with those? Okay, let's get up and try some more on your own. So you can head up to the boards now. Marker.
I know.
42.
Okay, number one. Number two. Thank you. Right here.
It's just the thing. Actually, I'm not going. I'm just trying. Normally, 14 divided to 7. That's more. Yeah. Who doesn't put a line through? That's 29.
So we're gonna do three, so make sure everyone has a chance to do one. So two of you should be up on this one.
Think I did it?
Hey, talk to your partner here.
3, 2. Oh, you want a first step, right? Okay.
So -7 is pretty cool. We're not inspired.
Negative.
Hey, check around, see if your answers. You see this plus minus. It's fine. Yeah, you can just say 37. So 36 minus 7. You're right. Okay, so I got a bunch of 37, or -2 for the first one. And, yeah, good. Okay, here's the third one. Just this one up here. Don't worry about this one right now.
That one's gone.
No, he's right. Stop taking weird pictures. Get over here.
Why you even? Why?
Oh my God, I hated that. It's very hard to concentrate
No, you're playing. You're wrong.
Would you like to do it?
Well, first you. I'll go to this. No, you gotta go to this.
No, that's what I was telling you. It is. It's my God. You guys think you're 7 so weird. Is that right? My 7 you're smart.
Oh, what is that? iPhone 1? iPhone 9? iPhone 9?
iPhone 6.
36.
iPhone 7.
But I heard. Yeah. That's right.
iPhone 9? You know, you.
Yeah.
64 divided by 4. Isn't it 12?
What?
Yeah, 16. Times negative 4. Times negative 4.
Times negative. And you're very nifty.
Positive 64. Why?
Ready? No,
No way.
don't. No, see one.
They just have a different answer than others.
What is the gangster kill? Something thing. Bro, have you seen him? He's wearing a gold chain like that, bro.
I know.
Party silly.
We're gonna scrap this question 6 because there's a little flaw in it. So I'm gonna scrap this one. Okay?
We did it.
It's the question, it's not what you guys are answering, so I'm not gonna stress about it. So let's do this one.
Ayo. Damn, you 40 parallel there. I you know, there's totally not you trying to draw how you fall, like it's definitely falls. I mean,
Oh, did you? Good.
oh, you did that like 10 days ago. You figured it out.
What are you doing?
Well, I tried both shots. 30 minutes. Wait, no, 30 feet. You try right here.
All right, you're good. You can erase.
Just not.
You guys good? You can erase. You guys good?
I'm not racing Brett. I'm racing.
So I think we've done a lot in our heads.
That's nice.
So what did we do? Where did 64 come in? Oh,
Sure.
sorry. Yeah. Oh, over there. Oh, okay. Sorry. Good. 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 All right. Good. Ready, Zach, come and sit down. All right, good. Great job with that. So this wasn't something we did in Spiral 2. We did in Spiral 1. We did in Spiral 2. But it kind of fits with number sense because it's about dealing with numbers. There's no algebra here. It's just dealing with numbers. All right, so what we're trying to do is figure out what is the better buy. So to do that, we're going to find something called the unit rate. Because remember, what we want to find out is the price for one object. That way we can compare it. Right now, obviously, the Walmart oranges are going to be more expensive because you're buying 50 of them. So, of course, it's going to cost you more. The question is it a better deal? So we want to know how much it is per orange. So how do I figure out what the price per orange at No Frills is? Yeah, and it's even right there in the question. It tells you what operation to do. So let's go 195 divided by 15, and what do we get? Let's have our calculators out. 0.13? So that means 13 cents per orange. Is it possible you could get something like 0.0013? Yeah, because especially if you're talking like grams, right? You're talking, it might be like a fraction of a penny each gram. Okay, so don't panic if you see that. All right, and then the second one, and you don't have to write this part down, the 1.95 divided by 15. I'm just putting it there to remind you where it came from. So the other one would be 7 divided by 50. And what does that get me? 0.14. Yeah, so which one is the better buy? Yeah. So we can see that No Frills is going to be better because it's cheaper by a cent per orange. And remember, we're not always going to get sucked in by the Costco effect. Remember, the Costco effect is, I call it that. It's where everyone thinks that just because it's bigger, it's going to be cheaper. And that's not always the case. I showed you that example of the bagels right at the beginning where it was actually cheaper to buy them separate than buying the club pack. And this one, it looks like No Frills is cheaper by 1 penny per orange. Okay, so it's not just which one is better, but also by how much. That's the justifying part. Good? Any questions there? I think this one we did pretty well. We'll skip that. All right, let's go right to the next page then and get to ratios. So the unit rate things came up when we were doing proportions, and it was our work with all the fractions that is what we practiced in the ratios. So what we have is if you remember, we have lots of different possibilities on how to do these. Okay, so one is to try and find an equivalent fraction. So for example, what did I multiply by 8 to get 24? Yeah. Times 3. So if I'm going to go backwards, what do I have to do? Yeah. And I think we might be able to do that in our head. 15 divided by 3 is 5. So that is a totally acceptable answer. Right? You just did some operations, some fiddling out, some thinking, and got x equals 5. There was another strategy that we learned, and that was if we have x over 8 and we want x, we can just take this 8 and bring it up here and go times 8. So, or we could say it is 15 divided by 24 times 8. So let's just punch that in our calculator right now. Doesn't take any long to go 15 divided by 24 times 8. And what do we get?
5.
Write this down. And we get 5 as well? Now, do you have a preferred method on this? Like, this looks like a lot of work, whereas here, this is common sense. So both are fine. The reason we might want to remember about this method is when it's not easy to see a good link, right? Like if this was 21, what would I multiply by 8 to get 21? That's not quite as friendly, is it? So that's where this strategy would come in and we wouldn't have to worry about that. Okay, that kind of pops up right now. What do I multiply by 5 to get 8? I don't think that's an obvious number, right? So our second strategy might pop up really nicely here. If I have divide by 8 or divide by 5, what can I do? Times by 5. Just like we had divide by 8, we can bring it up and multiply by 5. So what is 5 times 3 divided by 8? Again, simple operation to put in our calculator. Anyone get that? 5 times 3 divided by 8? 1.875. I don't think I would have been able to do some guessing like I could here. Where's times 3 times 3? That's not quite as nice. And that's where the second strategy is going to be very, very helpful. Okay. And in the third one, we had a strategy to deal with these ones. Do you remember what the strategy on this one is? Yep. Very nice. The ratio, as long as it stays the same, the ratio is the same, you can flip it. It makes our life a little bit easier. But again, do I see an easy multiplication? What do I multiply by 8 to get 25? Not a friendly number. I also can't go this way and say, what did I multiply by 10? Or how do I get from 10 to 25? Not easy. So that's fine. We've got our strategy. What am I going to do with that 8? 8 times. That's right. And so this becomes 8 times 10 divided by 25. Again, I think we're going to end up with a decimal. 8 times 10 is 80, divided by 25 is 3.2. Is that right? Thanks. Okay. We don't have to do it in our head. We can just grab our calculator there. So does that sound familiar? Ring some bells, yeah? Okay. So just answering the ratios is fine, but then using the ratios to answer real problems is where this comes into play. So on our next set of questions, we're going to take the scenario and simplify our work, or put it into a ratio so that we can solve it. So for every 16 minutes of programming, there are 3 minutes of commercials on the radio. How many minutes of commercials would there be if there was 120 minutes of programming? So, because this is all words, we want to set it up as a ratio. And my advice is to set it up in English first. So, we've got 16 minutes of programming over 3 minutes of commercials. So I like to do it in words first, because that really helps me keep everything organized. So it tells me 16 minutes. So does the 16 go on the top or the bottom of the ratio? Yep. And how many minutes of commercials? 3. Equals. How many minutes of commercials would there be for 120 minutes? Where does 120 go in my second part of the ratio? Yeah, again, because it's right there. It says programming. So this helps me keep this in line. And when I don't know, I can use an X. I don't know how many commercials for that part. This one might work. Test it out. What do you multiply by 16 to get 120? Is that a nice number? I don't think it is. If I do 120 divided by 16, well, 7.5. That might be okay. So if I go times 7.5, I could probably do that. What's 3 times 7.5? So that multiplication wasn't too difficult, so that would be okay. But if I was nervous about that, that's okay. I can solve it like I solved the other ones. I can set up the ratio like this right now. And then if I'm dividing by 125 or 120, what's the opposite operation? Bring it up and multiply. So it's 120 times 3 divided by 16. And if you do that math, you should also get 22.5. Yeah.
There's also the other way where you don't flip it and you just divide.
Yes. Yeah. There is a strategy too. You know how we just sort of set this ratio up? There is a strategy where we go, what is it we're trying to find? And put that on the top. So it saves us a step. So if you go, how many commercials? Maybe we set the ratio up where it says commercials over programming. So then we would get to 3 over 16. We would get to this step right away. Okay. Both of these are acceptable answers. You don't have to do both. Just do one that's going to get you the answer. Am I finished though? What am I missing? Yes. Because this is an English question, we have to finish with an English answer. So therefore, there are 22.5 minutes of commercials. Sentence doesn't have to be a big, long story, but it is an important part of the answer. Right. All right, let's try the second one. In our grade 9 student profile, there are 6 girls for every 4 boys. How many total students are there? Or there are a total of 200 students in grade 9. How many of them are girls? So our ratio then is going to be a little bit different. Let's read what I need. I need the number of girls, right? So I'm going to start with my ratio of that first. Except I'm not given the number of boys, I'm given the total. So I'm going to change this to total. Now you could, if you wanted, go and find the number of boys and then go off and try and go from there. But it's going to be harder when you have a total. You don't have the number of boys. We don't have the number of girls either. So this ratio is going to be a little bit easier. Now, so if we just change this last sentence, it says there are a total of 200 students. So that means this is going to be 200. What I don't know is how many girls. And I have to compare it to the ratio that I'm given. So I'm given 6 girls for every 4 boys. So what's my second part of this ratio going to be? 6 over 4. So we know the number of girls is 6. Do we have a ratio for boys in our setup here?
4.
Right, but we don't have a ratio for boys here. What I have is a total. In this scenario, what's my total number of people? 10, that's right. So let's just think about that for a second. 6 girls, 4 boys. How many do we have in total? If we just had 6 girls and 4 boys? Yes. So our total is 10. And that's what we need in this question. So it makes this one a little bit different. Okay. Now this operation, I think this one's not too bad. What do I multiply by 10 to get 200? Yeah, times 20. So times 20 there. And I think that's 120 in total. So therefore, there are 120 girls. That was a little bit trickier because of the total part. So we had to make a new ratio. Normally we would have said girls to boys, but the second part doesn't give us the boys or the girls, so it gives us the total. So we have to change our ratio to girls over total. Okay. Questions there? All right, our last bit of number sense is mean, median, mode, and box plots. Do we remember this? It's definitely been a couple of months for this. So this is where the review is going to be really handy. So it's been a while since we did this, but I feel pretty confident about this. So one of the things we know when we find the median is we have to do something to the numbers. Right, we have to find the middle number, but it's just not the middle number as given in the question. Very nice. And Sam used to be our person to help us with this, but she's not here, so I need someone else to help me put these in order from smallest to biggest. Help me out here. What's the smallest? 62. And then what's next? 68. 86.
90 and 90.
Two 90s, okay.
92, 93.
Thank you. People agree with those? One nice little strategy is to reorganize them right underneath the data. So then you know that you've got them all, right? Like if you stopped here with your largest number and you go, oh, I missed one, I forgot it, okay? And I would double check this. 62, definitely the smallest, then 68, 86, 90. There's two 90s, then a 92, then a 93. Okay, because it's in order, I can get one of the bits of information right away. What can I get right now? Yes. And what's the median then? 90. Yeah.
You could also pick the mode because.
Right. And remind me what the mode is?
Any reoccurring, like the most reoccurring number.
Good. The ones that appears the most. Is there any that appear the most?
90.
Yep. And having them in order really helps you calculate that. Is it possible to have more than one mode? Yep. So you just write down all the ones. You don't do anything to them. You just write them down. And if they all occur once, they're all the mode. So you just write them all down. Or you say all of them are. Okay? Okay, so what I'm missing, though, is the median. Or the mean, excuse me. Someone remind me how to find the mean? Yeah.
Add them all up and then divide them by the amount of them.
Excellent. So we're going to add them all up and divide it by 1, 2, 3, 4, 5, 6, 7. So we're going to add them all up and divide it by 7. So I'll give you a second to add those up. Actually, I'll help. I don't have that here. Bless you. I got 581. Anyone want to get that too? Awesome. Thank you. And what did I say? Divide by 7? So 83. That seem reasonable? Like if we were talking test scores, this person got lots of high marks and then they had these two that really brought their average down. That sounds about right. Okay, so add them all up and divide by the number that are there. Okay. What's next is to draw our blocks plot. So this might take a little bit of refresher. So we have to do Q1, Q2, Q3. We actually already have one of those. Do you remember which one you have? That's right. Q2 is right here. It's the median. So we know that we're going to have a median at 90. So I could draw a little line there. Actually, even before you get to the Qs, you could do your min and your max. So your minimum here is 62. So you put a dot at 62. And your max is 93. So you put a dot at 93. This is Q2. That's going to be in the middle, well, somewhere in the box. But now I need either end of the box. So I need Q1 and Q2. So what you're doing is you're breaking up the second half of your data. The first half of your data and your second half of your data. Q1 is the median of the first half. So which one is Q1? Thank you. It's right in the middle. And what's right in the middle of the second half? Two. And those are going to be the edges of your box then. So I'm going to draw one at 68 and one at 92. And now you could take your ruler. I think I'll just do this by freehand. So here's your Q1. And here is your Q3. Am I missing anything on my?
The whiskers.
Yes, the whiskers. And those are the straight lines that come out from the box to the lowest number and the highest number. So are there any questions right now? This is probably one that you'll want to make sure you have close by when you go to do your own box and whisker graph on the in the assignment to make sure that you see where all the stuff comes from. You could also pull out your test and find the one that you did on your test just to make sure that you match everything up. Okay? One thing I'm going to add here, what if you come down and you have numbers like this? So I'm just going to say, what if you have 10 and then 12 and 14 and 19? What's the median here?
You would have to add
Find the median.
14 and then
Wait,
divide by
no,
2.
the mean.
Say that again, sorry.
You have to add 14 and 12 up and divide by 2.
Yes. There are two medians here. So you go 12 plus 14 divided by 2, which is 26 divided by 2, which is 13. Can you also kind of see it's the number exactly halfway between these? Right? So your median is 13. Okay? So let's not forget about that because that could happen. That could also happen when you're calculating your Q1. Like if we had 4 numbers here, your Q1 would have to be the average of the 2 that are in the middle. And if you had 4 numbers here, your Q3 would have to be the average in the middle. So don't forget about that little part. Maybe you want to write that off to the side. What if? To remind yourself, if you end up with a median, 2 medians, we'll go from there. All right. How are we doing so far? Ringing some bells, which is really good. And I see some of you are really jumping on top of this and remembering it really well. So that's great. So now we're going to review algebra. And what's actually going to probably happen here is because we've done so much algebra since we did these questions, it's going to feel like we're better at it now than we were at the beginning. And I've already seen that already. So this is just a matter of a little bit of review. So let's go off into our algebra here. Collecting like terms, we actually did yesterday, right? So what we have to do is find like terms. What makes 2 terms like? Same letter. And it also has to be raised to the same exponent. So if we had an x squared and an x, think back to the algebra tiles, the x squareds were like squares, and the x's were just lines. You can't add those, they don't look the same, even though they both have an x in it, okay? So make sure that we separate those. One strategy I like to do is to underline the ones that are the same. And then we're gonna collect those. Collecting meaning adding and subtracting, gathering them up. The very first thing we did when we did collecting like terms was a Desmos activity with apples and oranges and bananas. Remember, you grab the apples together and the oranges together. So we're going to do that same idea here. What's 3x plus 5x? 8x. Just collecting them up. Be careful on this. This isn't 5y, this is negative 5y. So it's like I'm there, and then I'm adding how many? Where am I? Nice. Good job, Nathan. So minus 5y. Remember, if you just see a y, that means there's one of them, right? So minus 5 plus 1 gets us to minus 4. Can I add these together? No? How come? Unlike terms. Remember that little chiming that we had us do way back when? I'd say, can I go any further? And everyone would go, no. I say, how come? And you say, unlike terms. Okay, I'm not going to make you do that here, but that was reminding us of all the steps. Negative 4x collects with what? 8x. Anything else? No. Negative 4, kind of cold. Adding 8 of them. Where am I?
Positive 4.
Positive 4. Then negative 3y collects with negative 1, good. And the 2. So let's, I think it's 4 as well. Let's just say 3 minus 1, where am I? 2 plus 2? 4. So what do I write in between here if it's plus 4? Just plus. Same with this one. The answer was minus 4, so we just write down minus 4. Can I go any further? How come? Unlike terms. Good job. Expanding. We had a fancy name, a really fancy name for this. Rainbow, yes. Okay, the math name is the distributive property. Okay, it's rainbow. It's actually right here. Yeah, distributive right there, rainbow. So what we do is we say 3 is being multiplied by x plus 4. So it has to get multiplied by each part. Does the 3 get multiplied by anything else? No, just these. So now we're multiplying. So let's to make sure we don't add, right? Because we just did some collecting like terms on the top. We're going to multiply here. 3 times x is 3x plus 3 times 4. Yeah, 12. Okay, a common mistake I see is people say 3x plus 4. They forget to rainbow the second one. That's why drawing the arrows really reminds you to do that. What am I rainbowing the second one? A 2, that's right. Two times x. 2x. And then 2 times negative 1. What's a positive times a negative? Negative. So I write down minus 2. Am I done rainbowing? I'm done rainbowing, but what do I have to do? Sorry? Collect like terms. So all I've done is taken a complicated question and make it look like one of these. Now I do the exact same thing. I just add and subtract. Don't forget, multiplying is rainbow. Adding and subtracting is collecting like terms. So now it's just a matter of, that's 5x. And then 12 minus 2, where am I? Yep. And I can put these together and say 15x? No. How come? Unlike terms. Try the next one on your own.
Or y plus 6x.
All right, help me out here. You said, sorry, 4y what?
Oh, would you want the expanded form or the or just collected terms?
No, let's actually expand. We'll do the first step.
4y.
Yep.
Negative 12
Good.
plus 6x positive 2.
Very nice. Okay, so we're multiplying there. Now we're done multiplying. Collect like terms. Oh, this is weird. Got x's and y's in it.
Yeah, we do here too.
Yeah, I think that's a typo. I think that's a typing mistake. So let's just change the question here.
Well, we have y's on our page as well.
Yeah, I know. I think it's supposed to be an x. Okay? Is that okay? So let's change that. So it's going to be 4x. Now, if it was y, could we add them up? No, we would just leave the y and the x and we'd only add the numbers. But I think it was meant to be,
So equals 10x plus 10.
yes, 10x plus 10?
Yeah. Oh no, subtract 10.
Subtract 10? Because we're at negative 12, which is kind of cold, and then add 2. Sorry about that mistake. It looks like we recovered okay. Questions there? Again, have this handy when it comes to doing your algebra section of the activity. Okay, last part here, solving equations. All right, I'm going to go right to B first because B is the one we've done so many times before. This looks like y equals mx plus b, doesn't it, right? Mx plus b, looks like that. And we've solved these quite a bit. So if I skip around to this one, my goal is to get 2x by itself, or x by itself. What do I have to get rid of then? The 11, except it's a minus 11. How do I get rid of it? Add 11. Two x equals, and then what's 9 plus 11? Yep. Do you like it when I cross this part out?
No.
Minus 11 plus 11 and cross it out?
No.
Do you like that or no? No? Okay. We know that it disappears though, right? Minus 11 plus 11 is the opposite. Am I done? What do I gotta do? Bye. Nice. Let me get x equals 10. So the reason I wanted to do that is because that's our most common type of equation that we've been solving. The rest of the questions ask us to do some simplifying to make our equation easier, okay? So anytime, remember I said this before, mathematicians are lazy. So we're looking for ways to make questions easier. And because we know some of the rules, we can simplify them to do that. So over here, can you see a way to make 3x plus 2x easier? Yeah. Add them up, right? How many do I have? 5x. And how about here? Negative 18, which is kind of cold. Subtract 2 gets me colder. Where am I? Negative 20. And look, I've taken what's trying to be a tough question and simplified it. I want x by itself, divide both sides by 5. X equals,
Wait, Doug,
what?
thought you would like divide by one, get it to a positive.
No, x is positive right now.
Mm-hmm.
If this was a negative x, we would divide by negative 1, but this is just x equals negative 4.
Mm-hmm.
Is x allowed to be a negative number? Yep. Okay. How we doing? Okay, we're almost done the review, but we're also almost at break. So I think we'll do the last little bit of review after break. Maybe do a little bit of whiteboard, and then I'll give you the assignment. Okay, I think we have enough time, the second period, and I don't want to rush here. Like I don't want to just cram these in and then say, here you go, try your own work. Okay, so let's take 2 or 3 minutes here where you can just relax before the bell. And we'll finish this up after. All right, let's finish these last two review questions. Maybe do a little practice and then we'll be set for our assignment. So again, what we'd like to do is try and make the question easier than it looks right now. And one of the problems with this question is the letters are on separate sides, right? We've got a letter over here and a letter over there. Our strategy when solving these is letters on one side, numbers on the other. So we want to make sure that all the letters are on the same side. Preferably, the way I like it is to put the letters on the left side and the numbers on the other side. But there's no rule that says you have to do that. If it's easier to put the letters on the other side, no big deal. But I think this one is going to be better if we put the letters on the right side, or on the correct side. So this is 2x, but here's a minus 3x. Let's move this guy. What do I got to move? How do I move this guy? Plus 3x. Now, we might as well, while we're moving things, also move any numbers. Is this 15 okay right here? It is for a second, but eventually it's got to go over here, right? If we want the letters on the left side and the numbers on the other side, let's move the 15 at the same time. This is a plus 15. How do I move it? Subtract 15. All right. So, since I've added 3x, I got a 2x and a 3x. How many x's do I have? 5x. And then over here, nothing has to be done here. Nothing has to be done here. This is sometimes where the canceling is easy to see. So you make sure you don't do anything. But over here, I've got plus 5, kind of warm. Subtract 15. Where am I?
Negative 10.
Negative 10. And by doing our algebra, solving our equations, putting letters on one side, numbers on the other side, and collecting like terms, I've changed a difficult question into just like the ones we've done up here. And in one step, I'm done. Divide both sides by 5. Be careful here. What is negative 10 divided by positive 5? Negative 2. Right. All right. The last one that we have here, again, this is a question trying to act tough, but we have lots of skills to make things easier. What's one operation we can do to make this question easier? Rainbow. At the beginning of class, we did BEDMAS, where we added things in the brackets. How come I'm not adding these right now? Perfect. Unlike terms, so I can't. That's why rainbow comes into play, because the only way I can deal with this is rainbow. Does that 3 get multiplied by the 2x? No, it's not inside the brackets. All right, well, we just did some rainbow practice, so I think we're okay here. 3 times x is 3x. And what's 3 times 4? 12. I've seen this a lot where people do this, where they just write down 12. What's the problem with this? You're adding 12, that's right. So it's plus 12. It's a positive answer, so make sure you put plus 12. Plus 2x equals 28. So we've already made the question, which looks kind of tough, a little bit easier. Now it starts to look like maybe A or something like that. Can I make it even easier? Before I even do any of the algebra steps, can I make it even easier? Do you see any way to simplify it?
You take the 12 over to the other side.
Okay. I love that strategy by Landon. Does anyone else see anything that's easy? Yeah. Where's the minus 2x coming from? Oh, okay. I get what you're saying. But we want all the letters to be on this side, so we're not going to move it. Let's see what happens just when we have this here, and then you'll see what I'm talking about. So let's just do this step first. We're maybe trying to do too much in our head. So if the 12 is moved, I have 3x plus 2x left over, and then 28 minus 12 is 16. When we write it like this, we're not going to move that 2x. Can you see how we can simplify that? What's it going to be? Yes. Right? We're just collecting like terms now. Now, you might have done that at the beginning here, up here. Or not the beginning, but in this step. There's a 3x and a 2x and got a 5x. But writing them down in 2 steps is not a problem either. Does 5 go into 16? No. Is that okay? Yeah. We can still deal with this. Divide by 5, divide by 5. You have 2 options here. You're allowed to leave it as a fraction, provided it's reduced. Okay, and it's reduced when you can't divide anything into it, and that's reduced. Or you could go to a decimal. Yep.
Would be 5.3.
5.3?
3, like it'd be like and continue.
5.3333?
Yeah.
Is that what you're telling me? I feel like I've made a mistake someplace. Oh,
3.2.
okay. 3.2?
Yeah.
Well, help me out. Which is it?
I got 3.
Oh yeah, 3.2.
16 divided by 5. 3.2. That's right.
Times.
I get where you're thinking there, but yeah. Okay. So it's okay if we end up with a decimal or a fraction as long as it's reduced. I think it would be worthwhile before we go off if we just have a little bit of practice here. So let's go to the whiteboards. Just go back to the whiteboards and we'll do 3 more.
Wait. Ian, what's Trinity last name?
Okay. So there are 3 questions there. There's 3 people in the group.
B. U. Yeah. Let's go. We gotta go.
We do on this board here.
one of the folder forms, where you go
You mean the flip phone, the folder phone?
folder, folder. I made it on you.
Sure.
You did. I did it on my phone.
Those bees. This is like they only like 6. Dude, I need to start doing. I want to do. I want to do.